Today we did a few more challenging problems with circles, so I just wanted to show one of the examples that we did from the board in our video today. So this is the hamster problem that we did. Part A says, use the hamster wheel shown below and find A, the name of the circle. So the name of the circle is always the name of the center point. So the name of this circle right here is going to be circle B. Okay? Name 3 radii of the wheel. So a radius has 1 point on the center and 1 point on the circle. It is a line segment that connects those 2 points. So we have 3 radii. We have CB, BA, and BD. If BD equals 3x, so if this radius equals 3x, and CB, oh wait, no, this is BD. Okay, so if BD equals 3x, and CB equals 7x minus 3, they want us to find AC. Okay, well, we know that all radii in a circle are equal to one another, so we can set 7x minus 3 and 3x equal to each other. So let's do that right up here. And we got x equals 0.75. Okay, so x is 0.75. So they want us to find AC, so the length of AC. The length of AC is going to be this radius and this radius. So we basically just need to find the diameter, right? So let's find the length of one radius. Let's plug our x value back in to one of the radius. Let's plug it into the 3x radius, okay? Let's plug it into BD. So if we do that, we get 3 times 0.75 and we get 2.25. Now this is the length of one radius. We need the length of 2 radii because it goes from A to C. So we multiply this by 2 and we get 4.5, which is the answer. Okay, so next, I'm just going to clean this up a little bit, okay? Next, it says the measure of arc CBD is 85. The measure of angle CBD is 85. So this is, I'm going to use a brighter color so you can see. So this is 85 degrees. Find the measure of arc AD. Okay, so this angle over here is 85, and we want to find the measure of arc AD. Well, if we sectioned off this part of the circle, we would find that we have a diameter AC and a semicircle. So we know that whatever this angle is, when added to 85, they equal 180 degrees. So let's set up an algebraic equation in order to solve for the measure of arc AD. So we have 180 equals 85 degrees from this angle plus x, because we don't know what the measure of this angle is. So we do a quick little solve. We get x equals 95. So the measure of the central angle of angle ABD is 95 degrees. We know that the central angle is always congruent to the measure of the arc length, so the arc has to be 95, and it is. Next, E oops. It says, if r equals 3 inches, okay, let me clean this up again. If r equals 3 inches, so radius equals 3 inches, from here to here, 3 inches, find the circumference of circle B to the nearest tenth of an inch. So if we have the radius, and we know that the equation for circumference is 2 pi r, we can set them, we can put this value of r into the equation. We get c equals 2 pi times 3. We get c equals 6 pi. Let me multiply that out. And we get c equals 18.8, which we have up here. So we're good. Next, if there are 40 equally spaced rungs on the wheel. Okay, so a rung on the wheel are these little spokes where the hamster puts its toenails to make the wheel run. Okay, so those are rungs. So there's 40 of those on the whole thing. Okay. What is the degree measure of an arc connecting two consecutive rungs? So what arc length is one rung? Because it's connecting two rungs, so it's creating one arc length, right? Well, remember when we had the clock problems? We had 12 equal pieces. Remember? And we'd split them up to find what each angle equaled. Well, we're basically doing that over here, but 40 times because there's 40 spokes, right? So let's try to find what the measure of one of these angles created by the spokes is. Okay, let's try to find the measure of that angle. So let's see. We can set up a very similar ratio as we did when we were trying to find the measure of each angle in a clock. So in 40 pieces, there is 360 degrees. I'm setting up maximum to maximum. So we want to know how many degrees are in one piece. So let's cross multiply. We get 40x equals 360. Divide both sides by 40. And you get x equals 9, which is the answer right up here. So we're good. Okay. What is the length of arc CAD? Hold on. Okay. The length of arc CAD, okay, to the nearest tenth if the measure of angle ABD is 150 and the radius is 3. Okay, so what is the length of arc CAD if the measure of angle ABD is 150 and the radius is 3? Well, we're going to have to set up another one of our little ratios, right? So we're here in this one, we're comparing degrees to circumference or length of the arc, okay? So we're trying to find, if we take this piece out, we shall get this arc length measure, right? So we know that this is 150, right? We know that this is 180. So we can add them together to get the total degree measure of the arc length that we're trying to measure. So let's do that. And we get 330, okay? So the degree measure that we're trying to find is the arc length for the degree angle 330. So we're comparing degrees to length of the arc, remember? So we have our maximum degrees, 360 degrees, is to the circumference of this circle, which is going to be 2 pi. The radius is given to us, and it is 3. Okay? So we just found up here that 6 pi is 18.8, so I'm just going to erase this here and put in 18.8, okay? I would show you, but I am running out of room down here, okay? So this is the maximum degrees to the circumference. And then on the bottom, we're trying to find how much the arc length of a 330-degree circle in this circle would be. Okay, so we cross multiply, and we get 17.3. Okay, which is the answer up here, so we're good. Next, we have another question that's from tonight's homework, and it's about a new topic where we're finding the equation of a circle, okay? So you just did an exercise where you derived the equation of a circle yourself from the distance formula. So now we're just playing around with that information, okay? So this over here is the example, and then this is the question on this side, okay? So the question says, write the equation of a circle from the numbers center at 3, -2, and d equals 10, using the example on the right. Okay, so we always start with the equation of a circle, right? So we have x minus h squared plus y minus k squared equals r squared. Now, remember that HK is the center point of the circle. So in order to fill up this equation, we need the center point and we need what the radius equals. Does the question give us any of this? So the question tells us that the diameter is 10. So we know that diameter equals 2 times the radius. So we can set these equal to each other. We get the radius is 5. Okay, so we have our radius of 5, and we have our center point as right here as 3, -2. Okay, so now we're going to plug in the information from over here into the equation, and we will get x minus 3 squared plus y plus 2 squared equals 5 squared. And we will get x minus 3 squared plus y plus 2 squared equals 25, because we simplified. Okay? That is the answer to that one. Next question, it says, write the equation of a circle using the graph and the example on the right. Okay, so remember, we always start with the equation of a circle, x minus h squared plus y minus k squared equals r squared. Okay, so remember, we need two things. We need the center point, which the graph over here tells us is right here, 2, -3, okay? So 2, -3 is our HK. And then we also need the radius. So how do we find out the radius of a circle? Well, let's see if we can count over here, okay? So the radius is 1 box, 2 box, okay? So it's 2 over here. Over here, it's 1, 2 boxes. Over here, it's 2 boxes. Over here, it's 2 boxes. Okay, so we know that the radius is going to be 2. So remember, second step, we plug this info over here into our equation. Okay, and we get x minus 2 squared plus y plus 3 squared equals 2 squared. And then we simplify. X minus 2 squared plus y plus 3 squared equals 4. And that is our answer. Another quick example. So in here it says, graph the circle if you know the equation of it using the example at the right. Okay, so we need two things to graph a circle. We need the center, HK, and we need the radius. So let's write the equation of a circle first so we know what we're working with. Oops. Okay, so on this piece over here, we have our graph, and we have our graph right here, and then we have our equation up here. So H is always going to be in the first grouping, right? So right here. And since it's x minus h, I know I'm going to have to change the sign of whatever it says on here to make 4 positive in the center, okay? So I have positive 4. It's like when you were doing with the distance formula, remember? Watch your signs. So I have positive 4, and then k is the second in the second grouping, and it's plus 1. So we know that k is negative 1. So now we have our point at the center, which is 4, negative 1, and our radius, this radius squared is 9. So we need to undo that square in order to find out what r equals. So we get r equals 3. So now we have our center and our radius, okay? So let's plot this circle. Our center is going to be 4, negative 1. That's a really bad point. Okay, 4, negative 1, and then the radius is 3. So we count over 1, 2, 3 boxes from there. 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 Connect your endpoints, and you've got your circle. Last but not least, we have write the equation of a circle with diameter at endpoints A, 2, 7, and B, 4, 5 by using the example. Okay, so we have our axes. Okay, and it says the endpoints of the diameter are at 2, 7, so I'm going to plot 2, 7. Okay, so that's A. And B, which is B. Okay? Alright, so this has its diameter. This is the diameter of the circle, okay? So, if we were to draw a circle, it would look something like this, okay? Now, it says find the equation of a circle when it gives us the two endpoints. Okay, so we need to find the distance between A and B because that will tell us what the value of the diameter is, right? So we do our distance formula. Okay, so we have our two coordinates. Okay, and let's plug them into our equation. We get Okay, we get okay. So the distance between points A and point B, or the diameter, is going to be 2 times the radical 2, okay? So we have our distance between the 2 points. Now we need to find what the center of the circle is, because remember, we always need a radius and we need our center, okay? So let's see. Now I'm going to find the midpoint between A and B. I always start with my formulas. And we get x, 2 x's, 2 plus 4 over 2, 6 over 2 equals 3. The 2 y's, we have 7 plus 5 is 12 over 2 equals 6. So 3, 6 is the center of our circle, okay? So HK is 3, 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Perfect. That makes perfect sense in our picture. Okay, so now we have our center right here, and we have our diameter right here. Now, this is not in usable form for the equation because we need to find the radius, right? So, diameter equals 2r. So, in order to solve for the radius, we can do 2r equals 2 radical 2. Divide both sides by 2, and you get r equals the square root of 2. All right. Now, we have our radius and our center, so let's write our equation. So we start with the equation itself. Okay, and we get x minus 3 squared plus y minus 6 squared equals, radius is radical 2, so radical 2 squared gives us 2. So we simplify and we get x minus 3 squared plus y minus 6 squared equals 2. That's it.